In this lecture segment, we'll continue the walkthrough of mmind's target function. And let's do that by looking first at lines 9 and 10 here that have some variable declarations on them, a bunch of local variables for the target of mmind. And we'll generally drop that target phrase from now on, but don't forget that mmind's not really the function, it's the reference. Now, at a glance, these declarations look a lot like C or Java variables, but there is one huge difference. There are no types. It's not int numGames equals 0, for instance. It's just var for all of them, and var is nothing but a typeless keyword to announce variables. This is one of the hardest things for programmers of strongly typed languages like Java or C to get used to. Any JS variable may hold a string, a number, a Boolean value, or a reference to an object. Appropriate flags in the data itself indicate what type of content the variable has. But the variable is agnostic about that. Indeed, the same variable may hold different types of data as the program progresses. A language with this feature is said to be loosely typed. Loose typing is both liberating and at times irritating. You can declare and use variables and parameters much more freely under loose typing. But the data in the variable still has a type, and it's your responsibility to keep track of what type of data is in each variable. If you mess this up, the result is a runtime error when unexpected data is encountered, rather than a clear compile time error reporting a type mismatch. If you've only programmed in strongly typed languages, you may view variable types as almost inherent to coding, but they're really just a means of error checking your code before it runs. In JS, there's no compile step, and you do the type checking. Though its variables are typeless, JS's underlying data falls into two broad categories, much like those in Java. There are elemental types, number, string, and Boolean. You may recall those being discussed in the reintroduction to JavaScript. And there are objects, which includes functions and arrays, both of which are objects with special added behaviors. And again, the variables themselves do not fall into these categories. The categories apply only to the underlying data. Now, a variable that holds an elemental type holds the data directly, much like a C or Java elemental variable, like an int or a float, for instance. Diagram here of numGames reflects that concept. But a variable that contains an object is actually a reference to the object, and the object resides separately in memory, as in the diagram we have here for mmind. And again, this mirrors what happens in Java with references and objects. This reference-object distinction is as important in JS as it is in Java. And as in Java, JS objects are automatically garbage collected when no more references to them exist. Now, variables like guess or matches, to which no data has yet been assigned, do not contain simple garbage, as they would in C. Instead, they hold a special undefined value, which marks them as having no data at all yet. Let's add a diagram here for guess that reflects that concept. You can even test for uninitialized status via statements like if guess is equal to undefined. Now that's a lot better than C's you get random garbage because you deserve it for sloppiness, and it's perhaps better than Java's we'll cover your little mistake by supplying a 0 automatically. The variables on line 9 and 10 contain a variety of data types. NumGames and total tries obviously contain numbers. Model, as we'll see, contains a reference to an array object that is initially empty. And params contains a reference to an object, which is returned from a call of readParams. And that's a function that reads in the F4 game parameters and returns an object containing them. We'll look at readParams later. But since we have mentioned readParams, now's a good time to explain lines 4 through 6. Up here, the readParams function is in a different JS file, readparams.js. So are several other functions that are part of the overall program, each in their own JS file. we include these other JS files by the load command shown. This is most akin to a C #include directive. It directly includes those files into the current one as if they were directly edited into it. Indeed, it runs the contents of those files before it runs the file content that follows the load commands. Each loaded file contains a global variable declaration, rather like the one that we did for mmind right there. So by the time we reach line 8, we'll already have 3 function references, readparams, getGuess, and findMatches, that we can use to call their respective function targets. Let's diagram the 4 global variables we'd thus have, including mmind itself. So this is how you glue multiple files together in the same program, via direct inclusion. There's no compilation or linking, and the correspondence by the way of file names with function names is merely style. JS doesn't require correspondence of file and variable or type names the way Java does. So here's question 1 for you in this lecture. A bit ago I said that line 10 here shows a call of readparams, a function that does such and such. That's not exactly correct. What's wrong with that statement? And coming back from a pause there, I'm just reiterating the point we've made earlier. As emphasized in the prior lecture, that's a call of the target of readparams. Readparams, of course, is just the reference. Although, as we said earlier, we'll speak as though readparams were the function in most cases. Now, this may seem a pedantic distinction, but it's not. Programmers of traditional languages are accustomed to seeing functions or methods as permanent fixtures that get called, but not as dynamically allocated objects that can be passed around and copied from reference to reference. Become accustomed to this different view of functions, and keep in mind the underlying reality as shown in our 4 diagrams here. So let's take a moment now to glance over the body of the code in mmind's target, and note that one of the easy things to understand in JS are control structures, like a while loop there, for instance, or a for loop down here, a do while there, and a if statement right up here. So the structures here are familiar to anyone who writes Java or C code, and they work just like those same constructs in those other languages. So with all the other JS oddness, at least the control structures are friendly territory. And buried in the code here are some other familiar constructs. There's a conditional $:colon operation going on right here in the middle of line 16. And there's a break on line 18 there. There are increment operators scattered all the way around here. There's a numgames ++, for instance. There are string constants in double quotes. And again, all of these work just like they do in Java or C. Although, truth be told, the string constants have a deeper story that we'll get into. So let's examine JS objects a little more closely now. As we mentioned before, line 10 sets params up to point to an object that contains game parameters that were entered at the start. And I've added a diagram here that reflects that idea. We've got params pointing to an object, which content of the object we'll be filling in very shortly here. Now, line 12 is a debugging printf. It's the source of the curly braced output that we looked at just a little bit ago in the sample program run. The expression params.toSource is the first example we have of using a JS object. And again, it looks pretty familiar to any Java programmer. It would appear that we're calling the toSource method of params, or of params target to be really exact. And so we are. toSource is a built-in method of every JavaScript object. It returns a string that could be used in JS source code to set up the object, thus its name, toSource. Now, here's a repeat of that string from our test run of mmind, the output of toSource. Up top here in the diagram is where we've put it. Now, the enclosing parentheses that were in the output are just added by toSource, so I've omitted them here. But the curly brace notation inside of them is more than just a data dump, and that's what we're looking at here. This is an organized data format called JSON, JavaScript object notation. And it's so universal in JavaScript that it's almost a hallmark of the language. And as we'll see, it can be included in JS source code to initialize the content of objects. We'll get a lot further into JSON later, but for now it does show something interesting about JS objects. As you can see from the JSON we've got up here, a JS object is a set of key value pairs, which JSON shows in the form key : value. So for instance, maxchar is a key and its value is the string, one-letter string f, and length is a key and its value is the numerical value 4. The keys are always strings, although their quotes, as you can see up here, are optional in JSON in most cases. The values are the usual typeless JS variables. They could contain anything. This is a different viewpoint from the classic OO language view, in which an object is a fixed structure containing certain member data with fixed names. An JS object is more akin to what would be a hash table in a traditional language, with entries, which are called properties in JS, not member data or fields, with entries identified by string names. In particular, though we do not do it in this example, we can change the properties of a JS object at will, adding or removing member data. Try that in a language like Java. This flexible, sort of glorified hash table view of objects is usually termed dynamic objects, and it's a key feature of JS and of other scripting languages. What I'm going to do here is fill in the content of that params object to reflect this hash table-like appearance. Thus. Now, since functions are data, even an object's methods are just more entries in the hash table, with a key that is the method name and data that's a reference to the function to be called. And we can add or remove methods from an object, an even more powerful idea. And now that I've said that methods are just more hash table entries in the object, the alert reader may wonder why there isn't an entry for method toSource in that JSON string. This has to do with concepts we'll get to later, so if you notice that and were wondering about it, don't worry about it yet. But do look at the uses of params on lines 21 here and 23 and also down on line 31. All of the lines where we use it but 31 should be familiar to a Java programmer, and even a non-OOC programmer would recognize lines 21 and lines 23 there. They're just retrieving one of the properties, aka fields or member data, of params. But what's really happening is made clear on line 31, which I deliberately wrote in a more complex way, using the property name as a string index on params. Indexing an object does not necessarily mean the object is an array. The index operation in JS means object hash table lookup, using the string supplied in the brackets as the key, rather like the get operation on a Java hash table. So line 31 looks up the length keyed entry in the params hash table object, and in our case returns 4. Now it turns out that the expression params.length on line 21 here does exactly the same thing that line 31 does, but line 31 just does it more explicitly. The two expressions are synonyms, and you can use the dot notation instead of bracket notation anytime you have a fixed key. But the line 31 bracket allows another possibility. It lets you put any string expression into the brackets, while the line 21 dot notation requires a fixed key, as I just said. For instance, we could ask a user to enter a string into some string variable or some variable called tag, and then retrieve from params whatever property the user entered by just writing params bracket tag instead of using a constant string. You could write an entire JavaScript programming using only the more powerful bracket notation, but you'll irritate your reader if you're just using fixed string keys anyway, and the JS interpreter may run more slowly since it cannot predict what property your expression will fetch just by looking at it. Importantly, with either notation, you may add a new property to any object just by accessing the property using a key as though it already exists, and then assigning a value to it. For instance, if I wanted to, I could write, as I do in the transcript, params.keyToUniverse equals 42. And now, for all the Douglas Adams fans, params object has a property named keyToUniverse with the value 42. Thus, and I could retrieve it for printing just by using params.keyToUniverse. By the way, if you try to retrieve a property that you haven't added, say, I don't know, params.vogonpoem, you get undefined, just as with an uninitialized variable. Here's question number 2 in our in-lecture questions. Languages like Java generally supply a library hash table that you can use to keep track of collections of data, like, for instance, java.util.hashtable. Does JavaScript supply one? Look it up if you think you need to. Either way, tell me how I might, for instance, maintain in JavaScript a hash table of student GPAs, keyed by student name, with possibly hundreds of students in it. Coming back from a pause there, if you look at what we just said about objects, nothing prevents you from using a JS object as a hash table in the traditional way, indexing it by student name in this case, and assigning GPA number values to each property. Ultimately, you'd end up with hundreds of properties in the object. Adding a hash table library to JavaScript would be totally redundant. A JavaScript interpreter is already basically a big hash table engine as it is. So you've got hash tables built in. Here's question number 3 for you. Given what we said in just this lecture, write an if statement that would check to see in this hash table I just described if there's a student named Smith, and let's assume that the object we're using for the hash table is called grades. So I've got an object I'm using as a hash table of student grades. It's referred to by variable grades, and I want to see if there's a student Smith in there. Pause and think about that for a minute. And coming back from the pause, if the thing you want to write would be if grades, hold on here, if grades bracket Smith is not equal to undefined. We said that indexing by a key not in the object would result in undefined, recall. So finally, a bit of external research for you. This one's pretty easy, but it's highly useful. Do some research and find out how to create, without using new, an empty JavaScript object, one with no properties. And question 4 would be, write a very short declaration and initialization that sets up variables, say, x, to point to an empty JS object. The entire line should be 9 non-blank characters, just 9. Back from a pause and a bit of research here. You want to write var x equals empty braces. Thus, the empty braces is actually JSON notation, reduced to the lowest common denominator with just the curly braces and no properties to describe. We indicated that JSON could be used directly in JavaScript source, and here's the first example of that. And then question 5, finally, again with some external research and a review of the JSON notation that we described briefly already, write a single declaration and initialization that points variable student to an object with 3 properties, a first name of John, a last name of Smith, and a GPA of 3.0. And that last value, by the way, is a number, not a string, the 3.0. So in other words, I want something that looks like what I just drew here. And waiting for a pause there. Coming back, the answer is, again, more JSON. What I'll do is, adding it to this little display here, we need to do a var student equals, and then in curly braces, the JSON necessary to set up a first name of John, key value pair, a last name Smith, and of course a GPA of 3.0. Now, note that I am using quotes for the keys here, where I did not see quotes for the keys in the output JSON from the toSource method at the beginning of the program. The quotes are optional, and JS will add them for you if the key is a non-keyword. The only time you must have quotes is when you're giving a key like while or for or something like that, where there might be ambiguity.